So hello learner, once again I welcome on the class of Geotechnical Engineering first. So I hope you all are safe. So in the previous class we have discussed about the grain size distribution, and in grain size distribution I have discussed the sieve analysis, and as I discussed that there are two types of sieve analysis, coarse sieve analysis and fine sieve analysis. And in coarse sieve analysis and fine sieve analysis we have seen the different set of sieves, and after that I will discuss the how to perform the sieve analysis in the laboratory. So today I will discuss about the what is grain size distribution curve, and after that with the help of grain size distribution curve we will get the value of we will get the two parameters, that is called shape factor, and these shape factors are coefficient of uniformity and coefficient of curvature. And after that I will discuss the range of this coefficient of uniformity and coefficient of curvature for the well graded gravel and well graded sand. And after that I will discuss the relative density or density index. So I am going to start about the what is grain size distribution curve. So grain size distribution curve, that is also called GSD curve. So it is a semi log graph. It is the graphical representation between percent finer on y-axis in the normal scale and particle size on the x-axis log scale. So grain size distribution curve is a graphical representation between the percent finer on y-axis normal scale and particle size on the x-axis log scale. So if I draw the grain size distribution curve, so this is the particle size, and this value will be percent finer, and this is the normal scale, and this will be the log scale. So this is the grain size distribution curve. So three curves I have drawn: curve first, second and third. So the first curve is called well graded curve. Curve first is called well graded. This will be poorly graded, and this curve there is a missing of some size of the particle, that is called gap graded. So this is the graphical representation of, and this curve is called grain size distribution curve, GSD curve. So what is well graded soil? Well graded soil, it has good representation of grain size and wide range of soil particle. Curve 1, curve first represents well graded soil. Similarly, poorly graded soil has either excess or deficiency in the soil particle or similar size of the particle. Poorly graded soil has either excess or deficiency in the soil particle or similar size of the particle. Curve 2 represents poorly graded soil. In gap graded soil, some size of the soil particle are missing. Such type of soil is called gap graded. Curve 3 represents the gap graded soil. So with the help of this grain size distribution curve, we will get the value of, with the help of grain size distribution curve, we get the shape factors. And what are those shape factors? The first one is coefficient of uniformity denoted by Cu, and the second one is coefficient of curvature, Cc. So what is coefficient of uniformity? The first heading is coefficient of uniformity, Cu. So Cu is defined as the ratio of D60 by D10. What is D60 and what is D10? I will discuss. Similarly, coefficient of curvature, Cc is defined as D30 square divided by D60 into D10, where D10 is the effective size of the particle in which 10% particles are finer than this size. So d10 is the effective size of the particle in which 10% particle are finer than this size. Similarly, d30 is the mean size particle in which 30% particle are finer than this size, and d60 is the mean size particle in which 60% particle are finer than this size. So d10 is also called effective size of the particle in which 10% particle are finer than this size, and d30 is the mean size of the particle in which 30% particle are finer than this size, and d60 is the mean size of the particle in which 60% particle are finer than this size. So from this curve, once you have computed, so coefficient of uniformity can be computed d60 by d10, and coefficient of curvature is d30 square by d60 into d10. So how will we get the value of d10, d60 and d30? So if this is the gradation curve, this is the GSD curve, this value is percent finer, and this value is called particle size. So let us assume this is 10, 20, 30, 40, 50, 60, 70 and so on and so forth. So if I compute the value of d10, so corresponding to the 10% finer, this value will be d10. Similarly, 30 corresponding to 30% finer, 30% finer, you will get the value of d30, and similarly at 60% finer, read the value of particle size, that is d60. So this is the grain size distribution curve. This is called GSD curve. And once we have computed the value of d10, d30 and d60, so coefficient of uniformity can be computed as d60 by d10, and coefficient of curvature is equal to d30 square by d60 and into d10. Once we have computed the value of coefficient of uniformity and coefficient of curvature, so for well graded gravel, the coefficient of uniformity is greater than 4 and coefficient of curvature lies between 1 and 3. Similarly, for well graded sand, the value of coefficient of uniformity greater than 6 and coefficient of curvature lies between 1 and 3. If the value of Cu is equal to 1, it means soil is completely uniform, means curve will be vertical. So if the value of coefficient of uniformity is 1, means soil is completely uniform, and in this case if you can plot the grain size distribution curve, so it will be completely vertical. And for well graded soil, for well graded soil, our coefficient of curvature must be lies between 1 and 3. So these are the different points we have learned Draw the grain size distribution curve and compute the value of D10, D30, D60 corresponding to the 10% percent finer, 30% percent finer and 60% percentage finer, and compute the value of coefficient of uniformity and coefficient of curvature. And accordingly you can classify whether it is well graded gravel or well graded sand, or it is completely uniform soil, or it will be well graded soil. That will depend on the value of coefficient of uniformity and coefficient of curvature. So now I am going to discuss about the another topic, that is relative density, or also called density index, denoted by ID. So what is relative density or density index? So this term is defined for cohesionless soil. Relative density or density index will give the idea of looseness or denseness of the soil. So relative density or density index is defined for the cohesionless soil, and it will give the idea of looseness or denseness of the soil. Higher the value of ID, means relative density, greater will be the strength of soil, or we can say it will be highly dense. ID can be written as ID is equal to expression, if I write, so E max minus E natural divided by E max minus E minimum into 100. So this is the expression of relative density, where E max is the void ratio at the loosest state. E minimum is the void ratio at the densest state. And E natural is the void ratio at the natural state, and it can be written as E natural is equal to G gamma W divided by gamma D minus 1. So E natural can be computed by this formula, G gamma W divided by gamma D minus 1, where gamma D is the dry density, gamma W is the unit weight of water, G is the specific gravity of solid. So what is Emax? So at the when our void ratio at the loosest state, means maximum voids at that time in the soil, and E minimum is the void ratio at the densest state, means when soil is uh, highly compacted, then at that time the void ratio will be minimum, and it is called void ratio at the densest state. And E natural is the void ratio at the natural state, and the value of relative density and classification. So when our relative density is less than 15%, so it will be very loose 15 to 35, loose 35 to 65, medium 65 to 85, it will be called dense sand, and greater than 85%, then it will be very dense. So with the help of this relative density value, we can classify the soil as whether the soil is very dense, loose, very loose, medium or dense. This relative density can also be written in terms of dry density. So this is the value of relative density, and with the help of this value we can categorize the soil as a loose or dense. So dear student, today I have discussed about how to draw the grain size distribution curve and what is the use of this grain size distribution curve. And after that I have discussed about the relative density or density index, what is relative density and what is the significance of this parameter. And after that we have seen the expression of relative density or density index, that is id is equal to Emax minus E natural divided by Emax minus E minimum into 100. It is uh, expressed in percentage, and it gives the idea of degree of looseness or degree of denseness of the soil. Higher the value of relative density, greater will be the strength or greater will be the denseness of the soil. And after that we have seen the range of different range of the relative density we have classified accordingly. So in the next class I will discuss the expression of relative density in terms of maximum dry density, minimum dry density, and natural dry density I will drive, and after that I will discuss the consistency of clays. So take care of your health and happy learning.